Hi again. The next trend I want to take a look at is that of the ionic radius. Let's begin at looking at the cause of formation of ions. Metallic ions, such as something like sodium for instance, will want to attain a configuration that's stable, and stable configurations resemble those of the noble gases. Noble gases have full s and p orbitals at the highest energy level. So for instance, neon, 2s2, 2p6, that's a stable configuration. In order for sodium, a metal, to attain that situation, it would like to lose an electron. If it loses that 3s electron, it then resembles neon. The loss of that electron results in it forming a positive ion, or a cation. Sulfur, on the other hand, a nonmetal, it has the following configuration, and the nearest noble gas to it is argon. It can attain argon's configuration by gaining 2 electrons, and hence forming a 2 negative ion. So nonmetals tend to form negative ions. Carbon, which sort of lies in the center of the table, it has 2 options. It could either attain the configuration of neon or that of helium with equal ease. By gaining 4 electrons and developing a 4 negative charge, it resembles neon, or by losing 4 electrons and then by gaining a 4 plus charge, it will then resemble helium. If you take a look at your IB data booklet, you can see the ionic radiuses of many of your elements, as well as the charge that they tend to develop. I should draw to your attention that the noble gases don't have an ionic radius. That's because they don't tend to form ions as they're already stable. Let's take a little bit of a look at what happens to the size when an ion forms. In the formation of a cation, or a metal ion, let's go back to sodium. In order to become stable, it would like to lose that 3s electron. When that 3s electron leaves, we've now lost 1 energy level. As a result, the atom has become an ion and is now smaller. In the formation of an anion, which typically happens with nonmetals, our nonmetal is going to want to gain electrons. So in this case, sulfur tends to gain 2 electrons. That fills the 3p orbital, now resembling argon. The addition of those electrons causes greater repulsion, and that outer energy level swells in size. So our anions tend to become larger. Here's a look at the period 3 radii of both the atoms and the ions. Period 3 starts at sodium and moves across the table to the element chlorine. The radius of the atom here is shown in blue. In the case of the cation, which I've shown here in red, a positive ion, we can see that the positive ions are all smaller than the atom. Again, that happens because of the loss of an energy level. The second trend we should notice in the cations is they become smaller as you move from left to right across the periodic table. That happens because we have a greater nuclear charge, a greater number of protons in the nucleus. That greater number of protons results in more pull. Conversely, if we look at our anions, which occur as we move from the elements phosphorus, sulfur through to chlorine, those tend to gain electrons. That gaining of an electron results in greater repulsion in the outer energy levels, resulting in a swelling of the atom, and it becomes larger in size when it forms the ion. You should also notice it follows a similar pattern to our cations in that they get smaller as you move from left to right. And again, that happens because of a greater pull from the nucleus because of the greater number of protons. The final trend I'll take a look at is what happens as you move down a family. Whether it's a metal or nonmetal, all of the ions tend to get larger as you move down a group or down a chemical family. That happens because we have additional energy levels. So I hope you found that clarified the trends in ionic radius. Comments are always welcome, and thanks for watching.